Okay, hi everybody. So today we are here, myself, Enrico Frumento, together with Maura Pintor. The topic of today meeting is to discuss, let's say, the uh, practical approaches developed within the project Sec4AI4Sec. That is an European funded project in which Sec4AI and the University of Cagliari are also partners. And the double-sided nature of the name derives from the, let's say, double usage of AI within the cybersecurity as a sort of offensive tool and at the same time a defensive solution. So something that needs to be secured at one time, can be used for the attacks, and can be used for defense itself. So the point is to attack the AIs, attack with the AIs, or defend the AIs and defend with the AIs. So we have four kinds of approaches by this point of view. And of course, there is also another project that is involved in this event today. That is the Uptake, which is a digital European program funded project, which aim is to develop a sort of DevSecOps toolchain and prepare some small medium enterprises to scale up within the European markets. So as a solution, the Uptake project is more on the side of, let's say, practical impact on the market, while instead the Sec4AI4Sec is an European funded project more on the research side. So, given this, I would like to handle the presentation, the microphone to Maura for her part. Thank you, Maura.
Thank you, Enrico, for the nice introduction. So, as anticipated, I will be talking a little bit about the project, the Sec4AI4Sec project, and I will focus mostly on one of the applications we have inside the project that is related to analysis of 5G traffic. But we will see in a minute what I mean. Okay, so the Sec4AI4Sec project, as you can imagine from the name, it's not really a spoiler, takes care of two sides of the same coin, basically. So the AI4Sec, I will start with this because it's naturally more easier to understand. It's when we augment regular systems that are usually related to software systems with AI. So one component of this big system will be taking decisions, and it will be doing that with some AI component. For instance, in the project, we are dealing with some aspects of identification, early identification of threats, like anomaly detection in network traffic, or even at the design time. So when we actually at the code development time, when we analyze the code we write or our developers write with AI tools, and also to prioritize what are the possible threats and things that can go wrong. So this is the first part, the AI4Sec. Just for convenience in the name, it's in the end. But the other aspect is that when you replace some deterministic process and some rule-based process with one of these systems, literature has tell us that basically they are sometimes weak. So now we are replacing a system that we know how it works with a system that is approximating something and in general works and works even better than the rule-based scenarios. But then there are cases in which it is easy to bypass. And then if you bypass an AI system, then you have a problem. So this is important, and this is why the project takes both together and brings university and academia and industry and even SMEs in a room together, so to think about this and to figure out a solution to this problem. And now I will go more in detail in one of the scenarios we analyzed, just to convey what is the general idea. So here is not the contribution of University of Cagliari for now. It's something that several companies and universities are working on in the project. It's one of the three pilots. And you can see it is, I mean, it's a lot of stuff, but the part we focus on is that here there is the 5G network, and here there is the internet. So the internet, we know, the backbone that connects everything, I mean, including the devices connected to the 5G network, to the rest of the world. And the idea is that we want to put an AI component that is very, very tiny, but it is in charge of filtering the traffic that comes and goes between these two networks, filtering what is potentially an attack. So the problem is very simple. We have a lot of packets that we don't want to know where they are going. The thing we want to know is whether they might cause issues. So we want to predict. To do so, there are several algorithms. One of the most used is actually anomaly detectors. The reason is because you don't know actually what is going to be the anomaly, so what is going to be the problem. The attackers might have several strategies, so you cannot really understand what is going to happen in the future. And then if you're a company that deals with this, the first thing you do is hire a machine learning engineer, give them the network, the 5G core network traffic, and tell them to apply, to do their magic, to do the machine learning stuff. There are several problems with applying this approach without involving some cybersecurity expert, some 5G core network expert, and so on. And this is what we did in this publication that you see cited in the bottom, where we analyzed the system, taking it as a predefined system, and found several issues that lead to potential issues later on. So first set of issues we found, I will show you an example of these that will make it super, super clear. But the first issue we found is that in training, you need to take care that the data that you're feeding to this system to learn the kind of distinction between what is an attack and what is not, they need to be cleaned. They need to be very, very polished so that you don't inject actually some bias. And this bias is given by the environment that you are configuring, and I will show you an example, and even the fact that you have a machine learning person that is dealing with data that they don't know what they represent. And this happens a lot. So in the paper, I will not show the extensive things we did in the paper, but we draw 4 training guidelines to avoid this problem in the training pipeline. And then on the second part of the paper, we actually analyze even how these systems are evaluated. And the real problem here is that you might evaluate it and find that it has a very, very high detection rate, very low false positives. But in the end, if you put it in the real world, you will see that these performance don't match what you expect from the system. Even worse, over time, because the traffic might change, you will see a drop that is continuous over time, and then after a while, you have to throw away the system. And so in the paper, we also write these 3 evaluation guidelines. So if you're interested, they are more specific to the 5G, but they are also generally applicable to many of the cybersecurity concepts. Now I will show you an example of both. The first one, the training issues. As I said, let's put ourselves in the shoes of a person that is tasked to create the system. What they will do is, okay, we need data. So we'll either you capture it from the wild, but then you don't know what is an attack and what is not. Or what you can do is actually create software that creates the data. So they will put up their environment, and make some people do some benign traffic. So tell them just navigate these websites and so on. On the other side, you have people that simulate an attack, and then you label those packets that are passing that are attacks. And that's it. Then you close the box, you give this to the machine learning system, and the machine learning system learns perfectly everything. But then we opened this box after this box that was developed during the project, and with our feedback, they found out a very big issue that this simulation scenario that they created was assuming something on the data that is not actually true. So I'm gonna be direct with the problem. The traffic they generated was of a completely different distribution from the traffic they had in the benign situation. So the attacker and the benign were clearly separable, but not because they were separable in reality, but because they used a different protocol. So if you feed this to a machine learning system, it will learn that I don't care about the rest, whatever you are analyzing in these packets, just look at the protocol. And there are two problems. One is that then if you put this in the production, well, you will have that normal users that are benign, that are doing benign traffic, they will be misclassified, so they will have a misservice if they use the wrong protocol that is not supposed to be related to any attack. On the other hand, and it's even worse, if you're an attacker and you want to bypass the system, the only thing you have to do is modify the protocol that you're sending the packet with in the transport layer. And then that's it. Then the machine learning model is completely bypassed, and the traffic of the attack will not be labeled as an attack. And so this is one set of training issues that we analyzed and through which we designed these three guidelines, these four training guidelines. And then I will now show you also the other side that is slightly related to what I just said about the attackers. So on the evaluation, the main assumption that is problematic is that if you have these metrics that tell you how many packets are detected, you're just not doing anything special as an attacker. But we know that attackers actually are adaptive. They will try to attack the system. If the attack is blocked, they will not stop. They will just change something to make sure that then, in the end, they will produce something that is attacking the system. In this case, we are talking about manipulations. So this is the system from before, right? The attacker that is injecting some packets. Then the attacker will apply some manipulations that are not breaking anything in the attack. So like the protocol change, for instance, the packets, the malicious packets still reach destination, and they will even bypass the system, the machine learning system. So as you see here, I represent them as red squares, red rectangles, but with a green envelope. That is simply some manipulations that are protocol preserving, and they are found with special algorithms that allow also some freedom here, specifically that we don't know exactly what system is in there. So it will just observe input and outputs to see if actually the attack is going through. And we show, of course, that because this model is not designed to be robust to anything of this, we are able to bypass it. So 100% these packets go through and they correspond to plausible attacks. So they don't break anything in the protocol. Second thing, we show that by applying the guidelines, as you can imagine, we reduce the sensitivity of the model to these perturbations, but it's not completely gone. So we are still able to conduct some attacks that actually succeed. And so this is kind of the bad news here. The good news is, though, that there is a lot of work to do. So this is why these kind of projects actually are very, very helpful, not only to universities, but also, to companies that want to sell this product. And they have even an advantage in selling after if they can at least prove that they did some additional testing. And in general, this goes towards the full pipeline, where instead of having individual tests, because these for now are individual tests and some guidelines that try to fix some points in the pipeline. But in a future, I would like to say a cohesive approach where we have some pipeline that is always looking at the model, looking at the data and checking that everything is going correctly. So this is why I'm also involved directly in developing one of these tools. I'm the main maintainer actually of the library Sec4AI Torch, that is something where we collect a lot of tools, testing tools for AI systems. We are now expanding to many other threat scenarios, not the only one, not only the one I've shown in my slides, but feel free to check it out. And this actually, to conclude, brings me to the new paradigms that are being accepted slowly, I would say, but they are starting to be recognized, that are the machine learning operations, so the regular life cycle of a machine learning model, with this new Sec style, Sec ML Sec Ops. Sec is some component that is in charge of analyzing security in these pipelines. And as you can see, you can do it in several places. So for now, we have covered mostly this part, where we test a model before we put it in the wild. And then in the future, and even with the regulations, they are working on the latest stages that are actually more difficult to completely close. But the idea is the same. If you are familiar with the DevOps life cycle, it's similar to the DevSecOps, where you try to shift to bring the security towards the left of the pipeline, to take care of security in every step, instead of just post-mortem when when the damage is happened. So this is just an idea, a small overview of what we do inside the Sec4AI4Sec, but of course, feel free to check out the project to find even more interesting stuff. And I'm just leaving a few links here. The one that I very much recommend is the course on machine learning security that is open to everyone, and it's also on YouTube. So if you're interested in this topic, there is definitely much more to find out there.
Okay, thank you very much for the insightful presentation. And now I am starting with another presentation that moves along the same lines on different kind of topic that is about the so-called vibes of AI. So I called the presentation the dam of vibes because it is an opportunity, of course, and I will mean vibes, I mean vibe coding, vibe, any type of things that could be easily deployed and developed through AI systems. That, of course, brings also the problem of DevSecOps, dev security. There are some aspects that needs to be taken into consideration. And here you can see also the logo of the Uptake project that is responsible for, let's say, scaling up a different, let's say, set of companies, all having products on the, let's say, the DevSecOps tool chain in order to, let's say, being able to compete on a larger market. So I called them a vibes, problem threats, points of attention, and some stories by the point of view. Just briefly, who I am, I'm, let's say, working on cybersecurity since a lot of years actually. It was not even called cybersecurity when I started. And I work on these kinds of areas, cyber crime intelligence, offensive security, social engineering, and of course, AI security. The point, one of the things that I usually hear when, let's say, a company starts to mumble about the impact of vibe coding of let's say, running behind the, let's say, tremendous race on staying up to date with AI technologies is that thanks now we have no time, we are too busy to look around. So on one time there is the fear for these new kinds of innovation. At the same time, since companies often say that are busy, there is let's say a sort of ways to adopt these kinds of new solutions as fast as possible. So there's a sort of this sort of dilemma that is normally called the Goldilocks challenge. That means adopt too early or too late these kind of technologies. By the generic point of view, this is something that is, let's say, in the area of AI coding, especially, is something that can be transformed from the usual make or buy paradigms into a make or use. Well, or use is something that is present since a lot of years because using, I mean, open source products just ready to be used. So make or buy actually was make or use or buy. But today there is another term that added to the list of these that is generate. So you can see there are a lot of companies that started to generate their own code independently, often as a sort of one-man team that is partnering with Cloud Code or Codex or any other kinds of advanced AI and developed in very rapid time frame very complex solutions. The network is full of stories in which there are people that went hiking in the mountains during the weekend, and meanwhile, their AI system were developing the next astonishing business that make them, let's say, gain a lot of money. But the point is that this is just more a kind of story because the reality is a little bit different, and this is what I'm going to somehow dig into. So we are for sure at the dawn of vibes. The dawn of vibes means that AI coordinates relates development, but it's also manufacturers that code. That means that kind of code that is developed by an AI, but no one knows exactly how it does what it's doing. And of course, this DevSecOps restores the human control and validation, but at the same time, it's becoming difficult because the point is that if the code is developed by AI, we are not actually moving to the left, you are moving to the right when the code is already deployed and built. Because of course, one of the things that is not present in the AI landscape is AI are able to build or develop secure code. Because most of the AI are able to stress test code already developed, like for example, Claude Mythos or any other cybersecurity enabled model, but at the same time, they are not able to securely code and produce code that is secure. So this is just a limitation that needs to be considered. So the unknown vibes means vibe working, vibe engineering, vibe coding, of course, vibe knowledge, hacking, reversing, everything. Vibes is entering a lot of different kinds of, let's say, specializations within the cybersecurity context, but not only within the cybersecurity context. So just to give an idea, just limiting to the cybersecurity, there is the vibe coding, of course, there is the vibe hacking, reversing, phishing, vibe red teaming, vibe threat modeling. That means actually to speed up the creation of artifacts structure, for example, a threat model, uh, or a red teaming activity with the help of an AI that, of course, does a lot of activities, let's say, leveraging the humans from a lot of duties, but at the same time needs to be incorporated in a sort of verification loop that guarantees somehow the quality of what is produced. And at the same time, it's the same kind of concept when you have an AI developed code. So the point is that, by the way, that AI typically go from the point A where as something to the point where that's kind of thing is developed through a very complex kind of path. If you look at the deep thinkings, details, or logs of any kind of model ranging from Claude Code to Codex to anyone else, you will see that there are a lot of back and forth in decisions. The modeling and the results is progressing in a very non-linear way. And of course, it's also progressing in a not only in a non-linear way, but in most of the times in a non-understandable way. So most of the decisions taken by this kind of model are not explainable most of the times and time dependent, because if you ask the same things on another day, moment of the day, you get a different route to get at the same point. So in this way, having the professional kinds of developments becomes difficult and very difficult. So AI should reduce for sure the workload, but sometimes increases it, because when you deal towards points B to the security of what has been produced by AI, you find very soon a lot of problems in understanding decisions, weaknesses, security problems, and so on. Reviewing these kinds of codes is becoming often quite complex, because there is a lot of dark code inside written by someone else, you and with which you don't have the possibility to interact and asks why have you done this that much. So there are hallucinations as well. The agentic system that self-corrects themselves, hiding intermediate errors and consumer resources through undirected processes. This is also often, you often see only the results and not internal, let's say, mumblings that many. And of course, the point is that it seems correct, it seems to work very well, but most of the time it's not secure at all. So the point is that if you repeat, moreover, if you repeat this kind of process during the days, for example, a multi-day, multi-weeks, multi-months process, the process becomes polluted very rapidly. What happens initially as a relatively near the so-called wow day, in which you see the tremendous advantage of having an AI that codes for you, this wow moment disappears quite rapidly as soon as you move forward to the, let's say, enterprise quality level of code. And most of the times you lose control of this kind of process, because, for example, I just resumed the process in a 5 day trip, and the day one it is quite of what I call the unique experience. So it's something that is the wow experience. You see code magically, automatically, I would say, created by AI. The shipping is very fast. It's a continuous iteration. Everything is fine. But from the day three onward, the things becomes to be less linear, because the agent contradicts itself. Sometimes the right code that was granted for stables takes different decisions, starts to loop. So at the end, you spend more time fixing what's most broken than building new things. So this is how the sort of vibe, let's say, vibe moment is deteriorated by these kinds of complexities that needs to be, let's say, the governance of these kinds of complexities is not that easy. Maura was speaking about the ML ops. Well, this is one effect of a missing ML ops, by the way. Well, sorry, this slide was in Italian, I forgot to translate it, but in a way, that says exactly what was said before. The instruments of programming are based on AI and produce obscure code that works if it is distributed, but no one have ever understood what it is doing. Indeed, that is what is written. Sorry, it wasn't Italian. And so the point is that all these kinds of things are built on top of the other, and so you are creating a sort of unstable structure that is working, you don't know why, and you don't know where could be broken. That is one problem for sure. And the point is also another, because there is another point that AI optimize for plausibility. So not only for simplicity, but on a long term, it becomes, it produces code that is working, is doing what it's supposed to do, but there are a lot of, let's say, constraints or uncertainties that remain under the hood, more or less. The situation is more or less like this house is a sort of, let's say, uh, comic type of image, but in a way it represents more or less this real situation. So abstractions layers that nobody can explain, blur the components boundaries, best practices as said before, there is a problem to solve, actually also, so a sort of over engineering. So these are all parts that are present inside the codes produced today. And of course, there's another interesting part. There is on the paper from IEEE that I mentioned that essentially say one simple concept. The more you ask an AI to patch its own code, actually it's not it's their own code, the more security hole it creates rather than fixing. So there is a sort of contradiction. If you ask the AI to produce more secure code or revising what it produced before, the final result is to have less secure code. It's a sort of paradox. Uh, Anyone who uses this stuff regularly pickups on this kind of behavior quite quickly. But what is that now has been documented in an IEEE paper that is interesting by this point of view. So it's a sort of let's say, marriage, the way of creating secure code with current LLMs. So it is for sure something that needs to have strong governance of what is of your development process, strong governance of the AIs. This means machine learning of ops and SecOps, of course. But the point is that it is also a very difficult kind of task, of course. This is why there are research projects on this kind of topics, because of course there is also another point that is beyond AIs, the last mile problem. AI can cover 50 to 70% of the efforts needed to create something, okay? Uh, and produce something that is production ready, secure or not, but anyway, production ready, okay? The mistake that most of the times is done is that the remaining 30% that is the human check is often skipped completely. So you see increasingly see a lot of products that have been completely developed by AI without this additional 30% of human validation, professional judgments, and so on. So you would then see a Tetris game like this that is working, but actually is not working very well. Okay. And of course, one of the problems that is was mentioned is that the supply chain is very complex. AI ingest a lot of packages, libraries, imports, Node.js element, whatever they things is needed for fulfilling the task. Okay, but most of the times you end up having a lot of components that you are not aware of. And of course, for example, this is interesting because the case of Light LLM, which was compromised with an internal malware that was automatically executed even before importing the component, just having downloaded that. And it was something that is very popular because it is often downloaded by the vibe coding agents and inserted into the Python programs. Uh, and so the numbers of users is 97 millions, but most of them are non-humans. Okay. And so this is a relatively complex situation. I would say I'm going to conclude, but anyway, nonetheless, the expectation are rising because I used this kind of tweet or well, not anymore tweets, they are X. That is quite interesting because it is from a developer of Anthropic the past year. I believe this new model in cloud code is a glimpse on the future we're hurtling towards. maybe as soon as the first half of the next year, software engineering is done. Well, the forecast is not respected, but in a way, the point on the long run is interesting. We won't bother to check the generated code for the same reason. We don't check compiler output. And this is interesting because it's the sort of where this kind of industry is heading to. Bringing all the problems that I said before, security, obscure code, problems of human inspections, and so on and so on. So that is where we are heading more or less. And the point is, therefore, the human in control. Humans needs to be in control of what the AI is creating, not only in the loop. So that is the important element. And just to conclude, this is the last slide. The future of engineering isn't a problem and pray. It is building an augmented workflow where AI amplify human design and humans are in and AI accesses. So a sort of that is human in control after all. And that's all on my side. So we are open for questions, but in a way, I would like to also have an opinion from Maura about these aspects from the research point of view.
Yeah, of course. I think we are going to reinvent software engineering, I guess, from what you said. And actually, I was looking at some recent papers that discussed that actually very stable systems that involve AI. Actually, the AI is less than 5%. So the rest is all hardness, and it's all basically just regular software design with the software architectures in mind and so on. What's your opinion?
Yeah, for sure. One of the things consistently seeing every single day is that on one side, the increasing importance of classic software engineering. Because, for example, one of the things that works very well is to let's say, use those kinds of good software engineering habits we abandoned because they were too cumbersome. For example, UML, class diagrams, business UML. That is all named today context engineering. Now, this kind of things that were used in the late 90s, more or less, when UML appeared, are very good to be digested by an AI, semi-automatically, and reduce the kinds of surprises in which the AI takes an independent decision on where, how, and what to develop. So, by this point of view, I would say that classic software engineering is becoming on a roar again. Uh, but at the same time, it needs to be adapted, of course, because you are not anymore. Well, Karpathy, the one of the OpenAI founder and the former chief of AI system in Tesla, said once that the new and hottest programming language is English. And that is interesting because if you go down into the complexity of prompt crafting, you soon realize that most of them are not simply English spoken requests. They have structures, a mix of code and language, so they are very complex. And it is a sort of programming language. So the point is that the humans are really going to program in something that is more related to English, so and instead of code. I know. And
Yes.
I also do a lot of programming courses in the schools and also in Sheffield because we do this kind of training for professionals. And one of the things that I usually say is that this last generation, for example, people around 20s more or less, though the last generation that learned to program manually and will not do it.
I agree. I agree. Uh, in a way, I share the concern for future generation. Um, so one thing first, I think the very big challenge here is that whereas in software engineering, maybe you can predict, sort of predict what comes in and out of a system. Um, in the context of AI, because we want it to be helpful and to be useful for everything, then we cannot really predict what's going in and out. And this is sort of a problem because then you cannot define a contract between different modules that have AI
Mhm.
in the middle. So yeah, this I agree. And for this, I tend to try to inspire my students to make them think, because of course their first concern is, oh no, we are gonna be replaced by AI. Why should I learn programming? Why should I learn anything? Um, my response is actually this, that no, we need people. We need people to try to design safe system and trustworthy systems, because now you can build an application in 20 seconds, but security is is completely another way of thinking. And
Yeah,
I mean,
yeah.
you can also delegate it to AI and let the AI figure it out, but I don't know.
Yeah, and this is interesting because if you build an application in 20 seconds, there is another side effect, of course. That is the same kind of evolution you saw when the digital photography have been introduced years ago. People were used to analogic photography, doing some sort of photographic compositions. Now, the advent of smartphones photography, for example, iPhoneography, that's a name, a weird name, but anyway, there was even books on iPhoneography. New types of compositions started to appear, so making a different use of photography in more creative way. What I see now is that most of the people are, let's say, astonished and recreating things, for example, that are already existing in a week, in a weekend. So most of the projects that I see around the vibe coded are, I recreated Slack in a couple of days, but Slack already exists, so it's nothing new. It's just a proof of muscle, proof of strength. The point is that I also see an increasing importance besides software engineering of new ideas, because we have a new instrument that is so powerful that is just waiting for people able to grasp that kinds of power to build something that was invisible before. And
Sure.
we don't see that yet.
And I see a parallel with photography also in another thing, that when every picture that you would take with a camera, you would have to pay for, developing and printing and so on. You would design better the process, and take the right angle, the light, and so on. Now we completely lost that care that we had for old style
Mhm.
photographies.
Yeah.
Now only have it for people with a Polaroid, that
Mm.
they kind of care about this. But the same is happening with software. You can take pictures, hundreds of pictures, but then you're gonna will be left with one that is not even as good as the only one you took with the previous camera, because you don't even care what you're doing. So I completely see the
Yes,
parallel
yes,
here.
yes. Yeah, it is more of a point and shoot kind of approach instead of quality and careful,
and
let's say,
and
managing
also
every
not
single detail.
I
Yeah.
yeah and not very efficient, and
Mhm. Mhm.
also, yeah, I would say less valuable. I
Mhm.
guess, because then you defer to um, maybe looking at the pictures, selecting the one that is the not the worst, and then you post that. But if you take
Mhm.
one single picture and you have one single take, then it's a different story.
Yeah. Yeah, and that is also an interesting trend in the companies. Because as Sheffield is doing innovation for several companies, one of the things that we see is that the developer inside the companies is taking new kinds of roles. because of roles. That means, for example, an HR responsible that is highly competent in the HR area, human resources, that immediately starts to develop something and release a website that actually is so useful because behind there is the knowledge and competence of that specific person that previously was, let's say, limited because he was not able to program anything or was not that important to develop a solution with a real programmer. So this is sort of, when you unlock the cows in a grass and everyone goes in its own direction. Yeah, well, that would be,
Definitely.
yeah,
And
interesting.
you end up not saving time.
Mhm.
Because then imagine that you work on you have three people working on some project, and then they develop their own solution with vibe coding, and then the real difficulty is when you have to put things together, and you cannot.
Mhm.
I mean, you can trust AI for doing that, but in the
Yeah.
end, it will take more time than just designing, having meetings.
Yes, absolutely, absolutely, absolutely. Because you leave the AI too much freedom to do choices. For example,
Without
implementing
direction.
the same kind of things in four different ways. Uh, and that's for sure. Yeah. Okay, so I think
Power without control, I would say.
yeah, exactly. Like a famous advertisement from Pirelli years
Yes.
ago. Okay, so I think that we are done. The meeting is, finishes now. So thank you very much for your intervention here, and thanks everybody for listening now and later as recorded.
Yeah. Thank you.